Hello everybody, so today I will talk about the system design of Dropbox, and today I will do the deep dive of the system design. So until yesterday, I talked about the high-level design, and I have three topics that I'd like to talk today. So number one, resumable upload and download. Number two, durability of the files. And number three, scalability of the system. That being said, I will start with the first one. Okay, so in the non-function requirement, I wrote that we'd like to support the fault tolerance. So this means that a resumable upload. So I will firstly explain what I mean by this. So let's say the user is uploading the file, which is 100, user is uploading a big file, like 50 gigabytes. And almost at the end of the upload, there is a kind of connection problem or maybe client-side issue, and upload failed. In that case, we don't want the user to start the upload from scratch. We'd like the user to upload the file, the remaining part only. Yeah. So that's what I mean by resumable upload. The reason for this is because number one, it takes much time to upload the file again. And also there is another issue that it uses the network resource. So that's why I'd like to support the resumable upload. And the same thing can be said for resumable download. So if user tries to download a big file and if it fails in the middle, definitely it should be started from the, broken moment. It should download only the remaining part. Okay, that being said, I will start with the resumable upload. So for the resumable upload, as long as we use S3, we can use the multi-part upload. So actually, I will explain the functionality of the resumable upload of S3 from here. So basically, resumable upload is if user tries to upload some big file, it is cut into the pieces in the front end, or I should say AWS SDK, maybe JavaScript or maybe TypeScript, and then it is sent to the S3 one by one concurrently. Then once they are all uploaded in the S3 side, they chunk them together into one big file, original file. So that's the S3's function named resumable upload. So I have a few things I'd like to mention about this S3 resumable upload. So number one, the mechanism. So as I said, the front-end SDK splits the file into chunks and upload it. And the thing is how S3 can know all the files are updated. So actually, internally in there is an API called complete multi-part upload. So this is a kind of signal that frontend tells backends that all the chunks are uploaded. So once that API is called in the backend, S3, S3 can know that all the chunks are uploaded. So now he start merging them into an original one file. And another thing I'd like to mention is how can S3 confirms that all the file chunks are uploaded without any loss. So, or I should say, how S3 can detect the corruption of the chunk. So for this purpose, the S3 internally uses the checksum. So for each chunk in the front end, it calculates the checksum and sends that checksum as well as the file content. And in the backend, it confirms that the sent chunk can, generate the same checksum as the one given from front end. So that's how S3 can detect the file corruption while the upload time. And okay, another thing I'd like to talk is how what happens if the upload fails internal in the middle of the uploading. How it can resume upload from the where it failed. The thing is, the S3 has their API, which is like the REST S3. Let me check. Oh yeah. So this one, okay. REST part API. So when frontend would like to resume the upload, it firstly hit REST part API, and that API returns the status of the upload for each chunk. And now frontend can upload only the chunks which has not been uploaded yet. So that's the mechanism how it resumes the upload. Okay, and let's say, okay, the other thing is, if the upload fails and if the client doesn't resume it forever, what happens? So there is the remaining chunks in the S3 which is not used at all. And actually this costs money. So even for the chunks, we have to pay the fee kind of to the S3. To avoid that, we should delete the chunk, so we can set something like the, let me check, life cycle rule of S3, so that those chunks are deleted maybe after a week or something. Okay, so those are something I'd like to mention about S3 upload. But as long as we use the S3 SDK, it internally does the multi-part upload, so we don't have to take care of it actually. Okay. So maybe now I'd like to talk about the resumable download. So the mechanism is quite similar, but in case of S3, resumable download is realized with HTTP range header. So HTTP range header is something like, hey, I'd like to download the file, but I'd like to get the file range from, let's say, 0 megabyte to 100 megabyte. Or maybe we can specify 300 megabyte to 500 megabyte. So in that way, S3 client side can specify which range of the file he'd like to, which part of the file he'd like to download. And in this way, the client can download the file chunks, concurrently. But in case of AWS in case of S3 SDK, as long as we use SDK in the front end, it internally does this. So we don't have to take care of that mechanism at all. Okay. Next, I will talk about the durability. So I specify durability as one of the non-functional requirements. So durability is here. So we store the file in S3. So we'd like to definitely guarantee the durability of the file in S3. So yeah, this durability discussion is also about the S3's internal mechanism. So firstly, I can say, when I search S3 durability, we can find this number, so 11 nines. So AWS 3 engineered for, 11 nines to data durability. So S3 natively guarantees the very high durability, so we can use it. And internally it uses multi-AZ redundancy. So internally in S3, the file is duplicated um, into multiple AZ availability zones. So availability zone corresponds to one data center. So the file is in multiple, data centers. So even if one availability zone goes down, or maybe it is, yeah, kind of there is a big disaster there, the file in another availability zone is still available, or I should say, still, um, persisted. Yeah. So as I said, durability, because S3 guarantees a very high durability, 11 nines, this durability non-function requirement can be met as long as we use the S3. Okay, so now I will talk about the scalability. So 100 million daily active users, 50 gigabyte per file. So basically, we talk from two perspectives. Number one is throughput. So whether, I mean, it's all about requests per sec. And the other side, the other perspective is the file size. Because each file is 50 gigabytes per file, this is quite huge. I have to take care how much data we have to store in a server side. So I will start with the throughput. So because we have 100 million daily active users, let's assume each user has one device. So there one 100 million device, and we have some APIs. So create file metadata, upload file, yes, file metadata. So I will talk about the first three. Okay, so I will discuss especially the get file metadata API and get updated file API. So I mean, the yeah, because for the get file get file metadata API, this is a read, and I can say when there is one file upload, it is written by multiple clients, which means that read request per sec, I mean throughput, is higher than write throughput. So I will take a look at this get file metadata API, and also get updated files. This is also important because this is a short polling. The client keeps calling the backend again and again and again. So we have to take care if this doesn't load, overload the our server side. So first we get file metadata. So because there are 100 million users, and let's say there, let's assume that in each day there are maybe 10 gigabytes of data is, maybe this is too big. Let's say on average, but there are some pictures or images which may be uploaded. That being said, let's assume that 100 megabytes of data is updated by 10 million users. So 10% of the user update per day, and they update 100 megabytes of data in each day. So I will use this number. So, and of course, this is linked to 100 million users. So word daily active users is kind of tricky because even if the user is not active, the file should be downloaded, synced automatically to the front end. But now I assume that there are 100 million also users. Okay. Now, get file metadata API. So there are 100 million devices, and he'd write there are. Oh, and we need to know the file number of files. Okay, so 10 megabytes. Let's do this. So 10 files. There are 10 files uploaded every day. So there are 10 files which should be propagated into 100 million users. So per day. So this is exactly the request per sec. So this is 10 to the 9 requests per day, which is 10 to the 4, 10k requests per sec. Okay. So this is a good and handleable by one database. Yeah, especially when we use the PostgreSQL. So we use the PostgreSQL for main DB. There isn't specific requirement for database in my understanding. I think this works with DynamoDB or maybe Cassandra. Yeah, but here I go with the standard PostgreSQL. So 10k requests per sec. This can be handled by one date node of the PostgreSQL, because typically 10 to 50k requests per sec can be handled by PostgreSQL for read queries. But maybe we can use the read replicas so that the read query can be handled by multiple nodes. Okay, and now I will talk about another concern: get update files. Short polling. So there are 100 million users, and they make the request every 1 minute. So there should be around 1 million requests per sec. This is so big number. Okay. So how can I avoid this? So the problem here is 1 million requests per sec. Oh, so sorry, I forgot to say something. So database layer, it can be handled. For the server layer, we can use the scalable, horizontal scaling, because the requests are stateless. So each server can independently handle the request. So yeah, I do the horizontal scaling. Typically, each server can handle 1000 requests per sec, so maybe we need around 10 servers. But we can use for example, AWS auto scaling, so that servers are scaled out according to the maybe traffic amount, or maybe S3 CPU or memory usage. And what I was talking about. So yeah, 10 million requests per sec. This is so huge. So I have to think how I can avoid this. How I can handle this. So for server layer, yes, I can use the horizontal scaling in the same way. Oh, by the way, because this is so heavy, I'm thinking of separating microservices here. again, download service should be available even if syncing doesn't work. The thing is, if the syncing doesn't work, maybe users like to open the UI in the web application and try to download the file from there. I think it should be possible even if the syncing doesn't work. Okay, so as I said, this is so, you know, heavy, like 1 million requests per sec. This is quite heavy loaded. I mean, DB is heavy loaded. So what can I do with this? Let me think. Something I can say, and I said, is using the adaptive polling. So if the folder is updated, so frequently, or user is actively looking at the folder, we should adapt the what should I say, thinking to be more frequent. But in the positive case, so I mean, thinking can be less frequent. So maybe in that way, we make this number to maybe 1 out of 10, like 100K requests per sec. But even with that, this is a bit heavy. Yeah, so of course we can use the read replica. So with read replica, let's assume each one can handle 50K. And in that case, we can handle, we need 20. Yeah, 20 read replicas. Yeah, I think it works. Yeah, we can use the 20, read replicas of the PostgreSQL. And in this way, the request can be handled, in the, yeah, I mean, 1 million requests per sec can be handled in the DB layer. So the thing is, we use read replicas. 20. Okay. So that's how it works. So we don't do the calculation for the write request because for write, as I said, it is less than the throughput of read request. But another factor I have to take care is especially the throughput of S3. And the thing is, S3 can handle the read or write request, so it can handle, so it can, how should I say, so S3 scales infinitely, I can say. So because S3 kind of do the sharding internally, so according to the object key, I'm not 100% sure, but S3 uses the kind of consistent hashing internally, and according to the object key, the request, both, I mean, either upload or download, are routed into the specific node out of so many, distributed servers. So in this way, as long as the request to specific one file is not so, the query to fetch specific file isn't super high, S3 can handle the request. Okay, so that about the scalability of S3. Okay, so now the final part. So scalability on the file size, storage size. So I put this number here. So 100 megabytes of file is updated by 10 million users. So number of files uploaded. Okay, so we have to take care of the file metadata, which is in the PostgreSQL, and also we have to take care of the file content in S3. So firstly, I can say for S3, we don't have to take care because S3 manages it. S3 can handle 50 gigabytes of data, and as I said, it uses consistent hashing internally, so it can handle big file size. And as long as we pay money, say, we can store more and more file. Yeah, but yeah, I will say this now because it is possible that there kind of the project, which is the whole folder, which is not synced so much anymore. For those folders, files, maybe we can move it to the cold storage. So in this way, downloading takes more time, but it costs much cheaper. So we can use the kind of life cycle of the file. And with that, those unfrequently used files are sent to the cold storage and we can save money. But this is for the cost efficiency, to be clear. Okay, and now I will talk about the file metadata. So file metadata is created per file. So as I said, there are 10 files. Ten files, and let's say there are 100 10 files, and what was I talking about? So there are 10 files, and yeah, there are 10 million users. So there should be 100 million records per day. And let's assume each file is 100 byte, 100 byte. I mean, each row is 100 byte. In that case, we have megabyte, gigabytes, 10 gigabytes of data per day. So in a year, it becomes 3 terabyte. No. Yeah, 300. Yeah, 3 terabyte. So this is completely fine because recently, PostgreSQL, let's say, for example, AWS Aurora, can store 256 terabytes of data. So we have 80 years to, run out of the storage of AWS Aurora. So this is completely fine. This can be stored in a single database of PostgreSQL. Okay, so that's it. And I've just noticed that there is something I forgot to mention. So I will quickly talk about it. So we have the S3 upload status here, and we expect that this status should be updated from uploading to uploaded when it is when the file upload is done. The way we can notice that is we can use the S3 push notification. So S3 notification. So S3 notification is something like when the file upload is done, S3 notification triggers something like AWS Lambda, and now that AWS Lambda can update the data in the database. I mean, S3 upload status column. That's something I will quickly write here. because it's missing now. Okay, that being said, I finished my today's practice. Thank you so much. Bye.